Something massive just appeared near Earth, and scientists are worried. Right now, tonight, as you're listening to this, a visitor from another star system is gliding through our solar system. Nobody invited it. Nobody sent it. It came from somewhere out there, a place we have never seen, a place we may never reach. And tonight it is closer to you than anything we have ever detected coming from beyond our sun. What you are about to hear changes everything. Stay until the end, because the final part of this story is the part nobody is talking about. Let me set the scene for you. Imagine our solar system, the sun in the middle, 8 planets circling it, everything we have ever known, everything that has ever been mapped or measured. That is our neighborhood. But our neighborhood is not alone. Beyond it, far beyond it, there are billions of other stars. Each one probably has its own planets, its own rocks, its own ice, its own wandering pieces of rock and dust. And every now and then, one of those wandering pieces drifts so far that it tumbles into our world. We call those visitors interstellar objects. And the one that just arrived is the strangest one yet. It was first spotted on July 1st, 2025. A small robotic telescope in Chile, part of a sky survey called ATLAS, picked it up. The NASA-funded system scans the sky every night looking for things that move. Most nights, it finds asteroids, boring rocks doing what rocks do. But this was different. The way the light moved was wrong. Too fast. The path was too straight to be circling our sun. Calculations were run again and again, and the answer kept coming back the same. This thing was not from here. It was passing through. Scientists named it 3I Atlas. The little I in the middle stands for interstellar. 3 means it is the third one we have ever confirmed. The first was a weird cigar-shaped rock back in 2017. Scientists called that 1 Oumuamua. Then a comet called Borisov flew past in 2019. Now this, the third ever. But where the first 2 were confusing in small ways, this one is confusing in ways nobody expected. And here is where things take a strange turn. This object is huge. Estimates pushed it at well over 10 kilometers across. Some say more. That is bigger than the asteroid that wiped out the dinosaurs. Picture that for a second. The thing that ended the age of reptiles. 66 million years ago, that rock was about 10 kilometers wide. And this thing, this visitor from another star, is in the same league. It is not a pebble. It is not a curiosity. It is a mountain moving through our solar system right now. But size is only the beginning of the worry. What really got scientists talking is what it is made of. Telescopes around the world pointed at it. The James Webb Space Telescope took a long look. Hubble joined in. The European Space Agency swung its cameras at it too. And what they found left people quiet for a moment. This comet is loaded with carbon dioxide, not the normal amount, an absurd amount. The ratio of carbon dioxide to water coming off of it is roughly 8-to-1. That is almost unheard of. Most comets in our solar system tilt strongly toward water. Not this one. This one is a dry ice machine wrapped in dust. There is more. Heavy water. Yes, that sounds like a science fiction term, but heavy water is real. It is water with an extra neutron in the hydrogen. Heavy water is rare in normal comets. But on 3I Atlas, the ratio of heavy water to regular water was about 1%. That is roughly 40 times higher than any comet we have ever seen in our own solar system. 40 times. Scientists stopped and stared when that number came in, because that number does not just mean the object came from far away. It means the object came from very old, very cold, very different conditions than ours. Think about what that means. The water on this thing was probably made in a place where temperatures were strange. Maybe a region around a star that is not like our sun. Maybe a region that is older than our sun. Maybe a place where radiation was different, where chemistry played by different rules. We are literally watching a piece of another world sail past, and we are reading its story by the gases. It leaks into space, and the leaks are not quiet. As it approached the sun in late October 2025, this thing lit up. Scientists expected a comet to brighten a little when it gets close to the sun. A little melt, a little gas, a modest glow. But this one brightened more than predicted. Way more. It was throwing off material as if something inside it was cooking. Some of the dust plumes around it stretched out hundreds of thousands of kilometers. That is bigger than the distance between the Earth and the Moon. Picture an exhaust trail longer than the Earth-Moon gap, from a mountain of ice and dust, from another star system. Now, some of you are already asking the obvious question. Should we be worried? Is this thing going to hit us? Let me answer that clearly. No. The closest it comes to Earth was around 170 million miles. That happens on December 19th, 2025. 170 million miles is far. It is further than Mars. It is far enough that we will not feel it, far enough that it is not a threat. But it is close enough to study. far closer than we have ever had any other interstellar object. And that distance is a gift. And that is why the worry is not about impact. The worry is about meaning. Let me back up and explain something most people forget. Our solar system is roughly 4.5 billion years old. Everything in it formed from the same cloud of gas and dust. The sun, the planets, the asteroids, the comets, they are all cousins. They all share a common origin. They all share the same chemistry, roughly the same recipe. So when we study a comet in our solar system, we are studying the same family we live in. We are looking at familiar material, familiar ratios, familiar fingerprints. But 3I Atlas is not family. It comes from somewhere else entirely, a different stellar neighborhood, maybe many light years away, maybe formed around a star that is now dead, maybe part of a cloud we will never see. When we look at this object, we are looking at a sample from somewhere we have never been. That is why scientists are obsessed with it right now. It is the cleanest sample we have ever gotten from outside. And the more they look, the more confusing it gets. Pattern interrupts for a second, because the public story and the inside story are very different. On the outside, you will see headlines saying, "Beautiful comet passing through, astronomers delighted." And it is a beautiful comet. It is a once-in-a-lifetime event. Priceless data. But behind the scenes, in group chats and late-night phone calls and closed-door meetings at observatories, conversations are happening that you will not see in a press release. Scientists are arguing about what this thing means, not what it is. We know roughly what it is. We mean what its existence tells us about the galaxy. Consider this. A normal comet is a time capsule. The chemistry inside it is frozen from the moment our solar system formed. So if you want to know what our solar system looked like 4 billion years ago, you crack open a comet and look inside. Now imagine what it means to crack open a comet that is not from our solar system. You're looking at chemistry from another part of the galaxy, maybe from a completely different era, maybe from before our sun was even born. When Webb analyzed the carbon in this object, the ratios of carbon-12 and carbon-13 were weird, lower than expected. Carbon-13 is built up over time as stars live and die. So if carbon-13 is low, the material is very old, older than we initially thought. That means 3I Atlas was not made recently. It was made long ago, maybe before our sun existed. Maybe it has been wandering through the galaxy for billions of years, maybe longer, and it just happened to drift into our path. Let that sink in. A piece of the galaxy, older than our own sun, is sailing past us right now. Why does that worry scientists? Worry might be the wrong word. Fascinate is closer. But here is the deeper question. If this object is so different from anything in our solar system, what else is out there? What else has been drifting through the galaxy, untouched by anything we have ever understood? And how often do those visitors drop in? Up until 2017, we assumed interstellar visitors were essentially zero. We thought the solar system was a sealed bubble, that nothing else ever got in, then Oumuamua, then Borisov, then 3I and Atlas. 3 confirmed visitors in just a few years. That alone is reshaping the math. It suggests these objects are not rare. They are common. They are everywhere. They are just hard to see until one happens to pass close enough for our telescopes to notice. So what does this mean in plain words? It means our galaxy is full of drifting mountains, full of shards from old planetary systems, full of chemistry we have never tasted, full of history we never knew existed, and every now and then one drifts through our neighborhood, like a postcard from somewhere we cannot go. And this one is the biggest postcard we have ever received. But hold on, there's a sharper turn coming, and it is the part that keeps some scientists up at night. Avi Loeb is a Harvard astronomer. He is the one who became famous years ago for suggesting that Oumuamua might not be a natural object at all. That suggestion made him controversial. Many in the scientific community pushed back. He was criticized, mocked in some quarters. But he kept asking questions. And now he is asking questions about 3I Atlas. He has pointed out that the timing of its closest approach to the sun, and its closest approach to Earth, and its closest approach to other planets is curiously tight, as if the object is threading a path through our solar system with unusual precision. Now let me be very clear. Avi Loeb is not saying this is alien. He is saying we should not pretend we know more than we know. He is saying the data is strange enough that we should not ignore the strangeness. Plenty of other scientists disagree with him. Plenty. I think this is just a weird but natural comet that got lucky with its flight path. And the honest truth is nobody knows yet. Nobody can know yet. We have only had this object for a few months of data. But the point is not whether Loeb is right or wrong. The point is that a respected Harvard professor thinks the data is strange enough to take seriously, and that alone raises the temperature of the conversation. Let me back away from the speculation for a moment and ground us. Here is what we know for certain. This is an interstellar object. It came from outside our solar system. It is unusually large. Its chemistry is unusual. It is rich in carbon dioxide. It is rich in heavy water. It is rich in methanol. Yes, methanol is an organic molecule, a simple one, the same kind of molecule that sits at the foundation of the chemistry of life. So in a quiet sense, we are being visited by a package that contains the molecules that make us possible, and we do not know where that package was made. Let that idea sit with you for a second. The molecules in your body, the proteins, the DNA, the sugars, all of that is built from carbon chemistry. The same kind of carbon chemistry we are sniffing in the gases coming off this thing. We share atoms with the stars. We always knew that. But we are starting to share atoms with other stars' systems too. Other stars, other worlds, other timelines. So the next question is the one trembling under the surface. Where did it come from? Which star? Which planetary system? Can we trace its path backward and find its origin? Some teams are trying. Using the trajectory measured by ground-based telescopes, they are running the math in reverse, extrapolating when the object entered our solar system, calculating what direction it came from, mapping that onto the local star field. If the math holds, we might be able to point to a star within a few light years that could be the birthplace. There are candidate stars. Some of them may even have known planets. Imagine that. Pinning down which star system this object was made in. Even if we cannot pinpoint a single star, the chemistry will tell us something. The ratio of different elements, the temperature at which the object formed, the type of star it formed, around. Whether that star was metal rich or metal poor, whether that star was hotter than our sun, whether it was cooler. We are essentially holding a baby from another star system and reading the birth certificate. And scientists are doing exactly that right now as you sit here on your couch or in your car or wherever you are listening to this. Somewhere, a telescope is pointed at this object. A spectrometer is splitting its light into colors and measuring what chemicals made that light. An algorithm is comparing those colors to our libraries of known molecules. And a notification is going to ping a phone somewhere when something new is found. That is how science works. Quietly, continuously. One photon at a time. So let me step back and talk about why this matters to you. Not to scientists, to you. If you have ever looked up at the sky and felt small, this object will not make you feel bigger. It will make you feel smaller. Nothing makes humanity feel smaller than realizing we are not special. That our solar system is just one of billions. That comets from other stars have been drifting past us forever. That we did not even know it was happening until a few years ago. The universe is not centered around us. And 3I, Atlas, is just the latest reminder. But there's another side. There's a beautiful side. We are the species that noticed. We are the species that built the telescopes. We are the species that pointed them. We are the species that read the chemistry. We are the species that could understand and what was coming from beyond. Out of all the species that have ever lived on this planet, we are the ones who saw a mountain from another star and said, "Tell me your story. That is something. That is genuinely something." And the more we learn about this object, the more we learn about ourselves. Because the chemistry of this comet is a window into the chemistry of the galaxy. If its water is heavy, the galaxy has more heavy water than we thought. If its carbon is unusual, the carbon path through the galaxy is more varied than we thought. If its methanol is rich, the raw ingredients for life are more common than we thought. Every measurement is a piece of the puzzle of who we are and where we came from. But let me bring us back down for a moment, because there is a part of this story that the mainstream coverage is not talking about. And this is the part I promised at the very beginning. So stay with me. The mystery is not really the chemistry. That is amazing, but not shocking. The mystery is the path. Watch this carefully. 3I Atlas came in on a trajectory that did something we rarely see. It passed near multiple planets in our solar system. It got close to Venus. It got near Mars territory. It got close to Earth. And the closest approach to the sun, the perihelion, came at almost exactly the right moment in the orbital dance of the planets to minimize the angle between us and the sun during the closest planetary passes. Astronomers call this an opposition alignment. And on January 22nd, 2026, Hubble caught it almost perfectly aligned with the Earth-Sun line. An alignment of only 0.69 degrees. Tiny. Suspiciously tiny. Now, I want to be careful here. Astronomers do not yet know if this alignment is natural or coincidental. Probability alone says some objects will appear to line up, but the timing has raised eyebrows. And when you stack the alignment on top of the unusual chemistry, on top of the unusual brightness, on top of the unusual size, on top of the unusual heavy water ratio, on top of the unusual origin age, the picture starts to look like one long list of unusualness. And that is rare, even for a comet. Either the universe is throwing strange dice, or this object has something we do not yet understand. That is the kind of statement that scientists live for. A mystery. A real one. Not a manufactured one. Not a marketing one. An honest Here is something we do not understand. Let us go find out. And the people chasing that answer are the same scientists you have heard about for years, the same teams working with the James Webb Space Telescope, the same Hubble operators, the same European Space Agency engineers who flew the JUICE spacecraft past it and got images from 18 million miles away. These are not hobbyists. These are the most experienced observers in human history, and they say this object does not look like the others. Now think about what it means for the next few years. This object is already moving away. By now, it is on its way back out of the solar system, out past the orbit of Jupiter, further, slingshotting past the sun and heading back to interstellar space. We will probably never see it again. If we miss the chance to study it now, we miss it forever. That is why the telescopes are running overtime. That is why the spectrometers are filled with data. This is a once-in-a-lifetime sample, maybe a once-in-humanity sample. The next interstellar visitor might come in 5 years, might come in 500 years. We cannot assume there will be another chance. This is one of the reasons this object carries weight. It is not just a science question. It is a stewardship question. Did we get enough data? Did we measure everything we needed? Did we ask every good question? Because when it is gone, the answers are gone. Let me tell you about one specific moment that crystallized this in the community. When the heavy water measurement was announced, a few senior scientists at major institutions went quiet for a day. They were not quiet because the result was wrong. They were quiet because the result was weird enough that they wanted to think before they spoke. That is how science handles surprises. By sitting with them, by checking again, by asking if the instrument calibration was off, by asking if there is some background contamination we missed. And after that day of quiet, the answer came back. It was not an instrument glitch. It was not background noise. It was real. The heavy water ratio really is 40 times higher than anything in our solar system. And that changes the playbook. What does it change? It changes our understanding of water in the galaxy. It changes how we think planets form. It changes how we think water gets delivered to planets. Our own oceans probably came from comets and asteroids in our own solar system. But if comets from other star systems have very different water chemistry, then the recipe for water in our galaxy is not uniform. Some star systems have heavy water, some have light water, some have mixtures in between. And that means exoplanets around other stars may experience different kinds of water than we have here. If you are a person who wonders whether life could exist elsewhere, this matters. Water is the foundation of life as we know it. The type of water, the chemistry, even the isotopes. Maybe some planets get the wrong mix, maybe some get the perfect mix. We do not know yet. But every interstellar visitor teaches us something about how chemistry gets spread around the galaxy. And 3I Atlas is one of the loudest teachers we have ever had. Now I want to step back and zoom out even further, because here's the truth. The Earth is small, the Sun is ordinary, our galaxy is one of 2 trillion galaxies in the observable universe, and yet every once in a while, a piece of one of those other places drifts past us. Tiny, quiet, almost invisible, and loads with it information that could take us 100 years to decode. That is the relationship between humanity and the cosmos right now. We are children, picking up shells on a beach the size of an ocean. We do not know the ocean. We do not know the shore, but the shells are real. And this one is the biggest shell we have ever picked up. But I want to be honest with you about something. Not every part of this story is wonder. Not every part is cute. There is a reason some scientists are worried. And the worry is not about danger. The worry is about humility. The worry is that we might be missing something because we are too confident, too certain, too stuck on our models. Think about it. Before Oumuamua, we said interstellar visitors were essentially impossible. Then we said, okay, rare. Then we said, okay, maybe a few per century. Then we found 3. The model keeps updating. The confidence keeps shifting. And every time we find a new visitor, the model shifts again. So the quiet worry in the field is this. What if our models are still wrong? What if it is not 3 in a lifetime, but 3 every year that we have been missing because we did not have the right tools? What if the galaxy is littered with these things and we just started looking? That is the kind of quiet hum in the back of the room at conferences right now. Not panic, not fear, just a slow realization that the universe might be stranger, busier, and more populated with wandering rocks than we ever thought. And that realization changes the way we look at the sky. It changes the way we plan missions. It changes how we think about planetary defense. It changes how we think about our own solar system. Because if interstellar objects are common, then the solar system has always been a busy place. We just did not see the traffic. And one more thought before we get to the end. A thought that I hope stays with you after this video is over. Every observer who has pointed a telescope at this object is doing something genuinely historic. They are reading the autobiography of a piece of matter older than our sun. They are listening to a voice from another star. They are translating it for the rest of us, and we get to share in that translation just by being curious, by watching, by wondering. That is one of the great privileges of being alive right now. And now, let me close this story where it began. On December 19th, 2025, 3I Atlas came as close to Earth as it ever will, 170 million miles, the closest any interstellar visitor has ever gotten. Telescopes around the world were watching. Backyard. Astronomers were watching. Kids with binoculars were watching. For a few nights, the whole planet pointed at the same point in the sky. And we all saw, together, a piece of somewhere else. That moment was bigger than the distance. That moment was bigger than the science. That moment was humanity looking up and saying, "Where did you come from?" We do not have the full answer yet. Maybe we will never have it. But we have some pieces. We know it is old. We know it is huge. We know it is chemically different from anything we have ever seen. We know it carried the building blocks of life. We know it took a path that made our astronomers look twice. We know it brightened more than expected. We know it has an unusual alignment record. We know it has an ancient origin. And what we do not know yet is what it all means. What we do not know is whether there are more out there. What we do not know is whether we have been visited before. What we do not know is whether the galaxy is full of messages we have been ignoring. That is the mystery worth holding on to. Not the fear, not the hype, the mystery itself. Because the mystery is real, and the real ones do not disappear with a headline or a comment section. They sit with us. They make us tilt our heads. They make us look up. And if you have stuck with me for this long, then I think you feel it too. So let me leave you with this. The next time you look up at the night sky, remember that somewhere out there, beyond the stars, you can see there's a rock bigger than the dinosaur killer sailing through our solar system right now. And on that rock are atoms that have been wandering for billions of years. And we got to see it. We got to measure it. That is not nothing. That is everything. If you want to stay close to updates like this, subscribe to the channel. We cover these stories as they happen. And if you have a thought about 3I Atlas, if you have a theory about where it came from, drop it in the comments. I read them. Real scientists visit too. And sometimes the strongest ideas come from curious people, not institutions. Tell me what you think. Tell me what you would want to know next. Because the universe does not stop, and neither do we. Something massive just appeared near Earth, and scientists are not just watching it, they are listening to it. The question is whether we are smart enough to hear what it is saying.